Welcome to The Explainer. Today, we are diving into an absolutely massive, fundamental shift in how we interact with technology. And this whole conversation was really sparked by a completely startling admission from AI pioneer Andrej Karpathy. Now, if you've been following the rapid advancements in AI, you already know Karpathy is a towering figure in the space. I mean, he helped build modern AI, he literally coined the term vibe coding, and he just has this unique knack for making complex technical shifts feel, well, inevitable. But recently, he made a confession that completely rewrites how we have to view programming and problem solving from here on out. So buckle up, because the way we build our digital world is fundamentally changing right before our eyes.
Okay, let's just jump right into this quote. I've never felt more behind as a programmer. Now, coming from someone like Karpathy, that is wild. It's incredibly startling to hear. So what exactly happened? Well, over a recent December break, he had some free time to just sit down and really deeply test the latest AI models. And he noticed a stark transition. Before, AI was kind of just this helpful little tool that gave you chunks of code, right? You still had to go in and edit it, but suddenly the code just came out fine. Then he asked for more complex stuff, and it was fine again. He found himself literally trusting the system completely, and it led to this hyper-fast workflow. He realized that if you're still looking at AI the way it was just a year ago, you are already completely behind. The old way of coding, it's dead.
So, let's move to our first major concept today. Section 1, the Software 3.0 Paradigm.
To really grasp why Karpathy felt so behind, we kind of have to look back at how we've historically commanded computers. Think of it in steps. Step 1, Software 1.0 is your traditional programming. That's humans writing out explicit rules and lines of code. Then came Step 2, Software 2.0. This was all about arranging massive data sets and training neural networks, creating learned weights. But right now, we are officially in Step 3, Software 3.0. By training these large language models on the massive multitasking environment of the internet, they haven't just learned language, they've actually become programmable computers themselves. Your programming language is literally just English prompting now, and the LLM acts as an interpreter, performing computation directly in digital space.
And this shift practically changes how you do everyday tasks. Take installing a program like OpenClaw. The old Software 1.0 way requires these complex, super fragile bash scripts. They just balloon in size because they have to handle every single different computer platform out there. It's a headache. But the Software 3.0 way, it is remarkably simple. You literally just copy and paste a block of text instructions to an intelligent agent. That's it. The agent looks at your specific machine, figures out the environment, performs the actions to make it work, and even debugs it right there in the loop. It adapts to you rather than making you adapt to the code.
And here's where it hits close to home for Karpathy. His very own project, the MenuGen app, was rendered completely obsolete by this new paradigm. His original app was this bloated piece of software built on Vercel. It used optical character recognition, image generators, all this middleware, just to translate a restaurant menu into pictures. But the Software 3.0 version? You just hand a photo of the menu to an AI model like Gemini and boom, it directly outputs an image with the food items rendered right onto the pixels. No middleware, no bloated app structure in between. The neural net does the heavy lifting directly. It's a real game changer because entirely new capabilities are suddenly possible that simply couldn't exist before.
All right, moving right along to Section 2, Vibe Coding versus Agentic Engineering.
So, if the old way of writing code is dying, what exactly replaces it? Well, we're seeing two very distinct approaches emerge. On one hand, we have vibe coding, and this is amazing because it drastically raises the floor. Anyone, absolutely anyone, regardless of their technical background, can quickly explore ideas and build software just by talking to an AI. But on the other hand, we have agentic engineering, and this is the serious professional discipline. This is what's required to coordinate these powerful, sometimes unpredictable AI agents securely and at a massive scale. Agentic engineering preserves that high ceiling of professional software quality. It ensures that as we move incredibly fast, we aren't accidentally baking massive vulnerabilities into our systems.
Because of this massive shift, companies literally have to tear down and rebuild how they hire. I mean, if you are still handing candidates traditional coding puzzles on a whiteboard, you are uselessly testing for an era that doesn't exist anymore. Instead, you've got to assign them massive, sweeping projects. Say, hey, go build a fully functioning AI Twitter clone. Then you demand rigorous security. And here's the kicker. You test their architecture by having top-tier, incredibly powerful AI models actively try to attack and break their deployed code. You are looking for an architect who can wrangle agents, not someone who just memorized basic syntax.
Which brings us to Section 3,
The AI jagged edge.
Now, we really need to talk about this concept of jagged intelligence, because it perfectly explains why AI feels like an absolute supercomputer one minute and then literally like a toddler the next. AI capabilities are incredibly spiky. They peak intensely in highly verifiable domains, things like math, coding, or chess. And why is that? Well, during training, labs use reinforcement learning. They give the AI clear, verifiable rewards when it gets the answer exactly right. But the second you step outside those specific, highly trained data distributions, the AI's capability just drops off a cliff.
So we end up dealing with this hilarious but kind of terrifying paradox. State-of-the-art AI right now can flawlessly refactor a massive 100,000-line corporate codebase. It can even independently discover hidden zero-day security vulnerabilities that top human engineers completely missed. But if you ask that same AI, "Hey, I want to go to a car wash 50 meters away, should I walk or drive?" it will confidently tell you to walk, simply because it's so close. It completely lacks the real-world common sense to realize that obviously you need your car with you to get it washed. That right there is the jagged edge we're dealing with.
To actually work with this technology effectively, we have to completely change our mental models. Karpathy put it beautifully. He noted that we are not building animals. These systems don't have intrinsic motivation, they don't do things for fun, they have no curiosity, and they definitely lack evolutionary common sense. They are statistical circuits. We are essentially summoning ghosts that are shaped purely by training data and reward functions. Yelling at your AI agent in the prompt isn't going to make it perform better. You just have to understand that you're interacting with a highly capable, yet completely alien statistical ghost.
Let's dive into Section 4, Building an Agent-Native World. Once you understand these jagged ghosts, you start running into a massive new frustration. For instance, when Karpathy reads software documentation today, he says it drives him absolutely crazy. Why? Because it's all still written for humans. He doesn't want to click around menus or read a 10-step setup guide. He just wants the one, clean piece of text he can copy and paste directly to his agent so the agent can go do the work for him. The future of our digital infrastructure is all about decomposing workloads into sensors and actuators designed entirely for agents to read and interact with, not us.
In this new world, it really helps to think of your AI as this brilliant, but maybe slightly inexperienced agent intern. It is amazing at memorization. Karpathy himself admits he doesn't even bother remembering the intricate API syntax differences between PyTorch, NumPy, and Pandas anymore, because his intern handles it perfectly. It just fills in the blanks. However, because it is an intern, and one without true aesthetic taste, the code it produces behind the scenes can sometimes be incredibly bloaty, gross, or structurally brittle. It gets the job done, sure, but it isn't always elegant.
And this lack of true, holistic understanding is exactly why human oversight remains absolutely critical. Here's a real-world example. During one project, an AI agent was tasked with handling user accounts. It noticed a user had a Google login email and also a Stripe payment email. Without human common sense, the agent just blindly assumed these emails should always match up to cross-correlate funds. But in reality, people use completely different emails for payments and logins all the time. The AI didn't know to create a unique underlying user ID. It just blindly matched the text. That is exactly why you have to remain in the loop.
And that leads us perfectly into our final section, Section 5, the future of understanding.
As we barrel toward this new reality, we have to ask ourselves a really tough question. In a Software 3.0 world, where you have essentially infinite, intern-level agents at your absolute disposal, just churning out code and processing data at light speed, what is the core human skill that actually becomes more valuable?
The answer is that we must elevate ourselves from being the laborers to being the directors. Humans remain the ultimate arbiters of aesthetics, of architectural design, judgment, and taste. Your job is no longer writing the basic for loop. Your job is ensuring the system's fundamental logic actually makes sense. You hold that complex engineering spec in your mind. You're the one enforcing the quality bar that prevents all that bloaty, dangerous code from breaking out into the real world.
It all really boils down to this one incredible quote. You can outsource your thinking, but you can't outsource your understanding. Look, AI can process the raw data for us. It can synthesize massive knowledge bases. It can even generate all the boilerplate code and do the heavy statistical thinking. But true comprehension, knowing exactly why we're building something, how it fits into the messy human world, and whether it's actually good, that remains uniquely, stubbornly human.
Which leaves us with this final provocative thought to ponder today. We are undeniably rewriting our entire world for Software 3.0. Our infrastructure is becoming fully agent native. But as these jagged models get smoothed out over time, and as these statistical ghosts get smarter and smarter, will humans always remain the irreplaceable core of taste and understanding? Or are we simply acting as the directors, just for now, until the agents learn the art of understanding too? Think about that. Thanks for joining me on this explainer. Keep learning, stay curious, and I'll see you next time as we continue to unpack the future.